Hello friends, this is me Hamad Rafiq and the topic I'm going to present is a brief survey on deep learning theories and end-to-end text recognition. I'm first year PhD student in School of Computer Science and Technology. I'm working under the supervision of Professor Kwan Chan and my research interests are empirical software engineering, information technology acceptance and blended learning. This is my email address. If you want to contact me, kindly use this email address. This is the outline of my presentation: introduction, research gap, related work, my direction, conclusions, references. So, stepping toward the introduction, syntax is one of the most general visual objects in nature scene. It frequently appears in front of our eyes on sign, road signs, license plates, product packages, signboard, nameplate, etc. So all the display text on various venues carries important messages which needs to be properly interpreted, detected, and recognized in order to detect the meaningful information. For example, you can see from the image that when a common person moves toward that building, they can easily recognize what that building's for, what is the purpose of that building. So what will happen if we will give a person with thousands of millions of images in order to extract the information? He will simply hand up. So for that purpose, there is a need of a machine which can effectively and efficiently recognize and detect text or information in order to interpret that information so that it will become helpful for the person. All information needs to be extracted very carefully and with the efficiency and within a short period of time. So there are main techniques proposed by various authors that are broadly categorized into three main categories. These are text detection and localization, text recognition, and end-to-end text recognition system. These all categories are further subdivided into other categories which are basically the combination or which are basically fall in these categories. I will broadly explain I will just explain the definition of all the categories and will focus on end-to-end text recognition because this is the main topic of my report. So, text detection and localization is further subdivided into three categories: connected component based, texture based method, and deep learning based method. What text detection do is basically that it take an input as image as an input or videos and detect the presence of a text and generate candidate text predictions or positions. So the subcategories of text detection do in that is connected component based method. It helps in finding and combining small components into large components, then filter out the non-text component by classifiers and display the textual information. In texture-based method, it extracts text from the image on textual properties, which can distinguish them from the background. In deep learning, what it do is that basically it use convolutional neural networks to extract the each and every information in order to get the productive information from them. So the deep learning is further subdivided into three regions, three branches, which is region proposal based method, segmentation based method, and hybrid method. What region proposal based method do is that it generate a small proposal of a region. For example, a small sliding windows which is contains moving on all the edges on all the pixels in order to calculate the weighted values, which are being then transferred to a small proposal there which is much larger than the input image, and these small proposals are being used in order to extract the information. So in segmentation based method, it generates small segments on an image to detect text with which more precise text regions were generated. It is used for multi-size oriented text. Mostly it is used for multi-size oriented text. And hybrid is basically the combination of connected component based method and texture based method. So when we talk about another recognition, when we talk about text recognition, what it has three categories, that is character based, word based, and sequence based. In character based, what it do is that it detects the characters from the image. For example, we have an image this and we want to extract the information from that logo of university. What it will do might it will do that it will extract university UINIVI. They will extract each and every character separately. But when we use this algorithm in word-based method, it will detect those words as a single word. For example, introduction, it will take introduction as a single word instead of characters. And when we talk about sequence-based method, what it do is that it extracts the sequences. It helps in detecting sequence of the word. For example, if we are giving a sequence or as an input, for example, 1, 2, 3, 4, 5, and we want to have another sequence from that, it will give us 6, 7, 8, 9, and 10. So the last but not the least is the end-to-end text recognition system. They are basically the combination of text detection and recognition. Why it is known as full end-to-end text recognition, because it is taking an image as an input, and after text detection and localization, it recognizes what type of text it is, and after that, it extracts information. It is performing all the steps which are being conducted independently on the above mentioned information. So before processing ahead, why there is a need to introduce these kind of techniques in order to test the information from the images? Why? Why there is a need? So there are different challenges which need to be addressed before extracting the information. What type of challenges? For example, I am going to mention few of the challenges like visibility issues, distortion issues, non-uniformity, background issues, orientation issues, and maybe some sort of text is missing or half printed, we will not be able to detect. For example, you can say that the orientation of text is like this, and there are small text over here, and you can see the light in front on the text which is not able to recognize even by human eye, and the image orientation, you can say the Royal London written in this image having the with the bright background as compared to text. So all these information need to be extracted in order to get the relevant information. These are the challenges which need to be addressed. That's why authors are proposing various techniques. So just proposing a technique and extracting information is not a main deal. The main deal is that whether their algorithms are working properly or they are extracting information as what we are expected or not. They are efficiently working or not. For that purpose, they have to evaluate their algorithm on the basis of some sort of benchmarks. They cannot generate their own databases as a benchmark, or they cannot generate their own lexicon or library for images. What they do is that they use benchmark databases which are being evaluated or authorized, recognized by various authors. So what they do is that they use such kind of databases or images databases for even image their training for the algorithm and for testing samples as well, which are being used for different purposes, which are mentioned in front of each data set, that are horizontal and text recognition, for example, end-to-end recognition, for arbitrary orientation text recognition, etc. So all kind of data sets are being used in order to evaluate the proposed algorithms or proposed networks. So now moving toward the main topic, that is end-to-end recognition system, in which first relative work is basically what is there. The key challenges in nature scene image is basically the detection of multi-oriented and small size text words. It is because words or lines of text in an image are close enough, which results in predicting the region which might be sticking together. For example, you can see in this image that we might not be able to detect 00 AM as a separate character. We might be able to detect that as single character, and this is basically known as sticking together of regions sticking together. So the for that purpose, in order to solve that issue, author proposed end-to-end trainable deep supervised neural networks detection framework for multi-oriented syntax. It has basically two branches, which are text no text classification and text localization, which works on text localization works in a way that whether the pixel in the text image is the text pixel or not, and text regression basically location regression basically helps us in detecting the regions of the text. This thing works on basically 5 channels, which have 4 geometrical boundaries that are top, right, bottom, left boundary of the text geometry, and the one of the rotational angle of the text region within an image. After that, NMS was applied, non-maximum suppression technique was applied in order to detect the overlapping of the bounding box. The data sets which they use are basically dataset are ICDAR 2015, MSRA TD500. So if we talk about the general architecture or the proposed architecture, what it shows us that it has it has four steps: feature extraction, feature upsampling, feature merging, and prediction in a network model. And at the end, it was all the output generated by them were given as an input to the NMS. What feature extracted do? That feature was extracted by using 3 stages of ResNet 50, which is followed by upsampling, which is followed by an upsampling, feature upsampling, as each upsampled feature predicts text region. All at the extracted features from all stages, stage output 1, 2, and 3, are used to extract the multi-oriented and multi-scale images, because all the extracted feature provide fine information, all granular information in order to extract the each and everything from an image. After that, all the predicted information are being combined and merged in order to get the final prediction. So one thing which need to be remembered or noted is that whenever we are performing any image or transaction or training of within a network, there might be some sort of loss which needs to be calculated on each and every step. So these outputs generated during while extracting the information from an image might face some sort of loss, that they might not give exact information which is present on the image. So they are also need to be calculated. If we talk about internal working of this algorithm, what it is doing, that it take an input and perform working on them while extracting the information, which take 64 feature of 7 convolutions, which is being run by 4 times on that layer, which give it will give us an output. So rest, even same as rest stage one, will give 256 feature with the 2 times running, which helps in upsampling. We have mentioned that we are performing upsampling with 2 times by 1/4 convolution layer, which is being run 64 features, and 64 feature about 3/3, and upsampling by 2. Similarly, we are again upsampling this image by 4, again upsampling by 8, and all these stages are giving a specific output known as output 1, output 2, output 3, and output 4. So all the output generated by these 3 stages and the one convolution layer were concatenated and merged to get the all information from that. So in order to get all fine information and granular information, what they did is that they adopted to already proposed or developed algorithm. What they do, or what are they known as? They are known as a holistical nested edge detection and efficient, accurate scene text detection algorithm. What HED or holistical nested edge detection algorithm do is they are basically detected the edges and provide features of multiple scales and levels. And what each do is that it gives core map and geometry of the text pixel in the text region. So after that, all the concatenated image which is being done with the help of the algorithm, information was extracted, was sent into the next level, which is called prediction level. It has 2 stages. One is text map and the other is geometry of corresponding text region. It is being done with the help of 64 feature with 3 into 3 convolution layer, which is further done by the 1 into 1 convolution with the 64 feature, 2 features. In this, what before working in this, what author did is that they quarterly upsamples the image. For example, we have an image S into S, and they quarterly upsample that image by S/4 into S/4, which will give them as text maps, and S/4 into S/4 5 graphs. Why 5 graphs? Because we, as I have mentioned earlier, that we are using 4 geometrical boundaries and 1 angle of that. So we are going to have 5 geometrical graphs. So when talking about the loss, as I have mentioned earlier, every stage, output stage, are need to be calculated with the loss, which can be calculated with the help of this equation. Loss is equal to loss of text plus loss of geometrical location. So the loss for calculated for this is that loss is equal to summation of m I is equal to 1 alpha I loss of I, where m is equal to the 4 outputs 1, 2, 3, 4. M is equal to 4, and I is basically the input of this. I is basically one input, where sorry, output, which is being calculated for the loss, and alpha is basically the alignment and loss of I. Similarly, for this equation being used for the value of the loss. If we talk about the prediction section, which have 2 sections, text map and geometry of corresponding text region, loss of text map can be calculated with the help of this equation, which shows that 1 minus 2 summation of S/4 into S/4. What is S/4 into S/4? It is basically, I have mentioned earlier, that we have quarterly rescaled or upscaled the images, from which we will get S/4 into S/4 text maps and 5 S/4 into S/4 text geometrical regions. Y static is basically ground truth value for ij pixel, and y hat is basically a text code map of the probability of ij pixel. Whereas the loss of text can be calculated with the help of the loss generalized dice location. Why we are using this? Because there was a series of unbalancing of the proportion of the text to non-text pixel. Therefore, for that purpose, for that unbalancing scenario, generalized dice location loss function and dice loss function was used, as it outperformed in this scenario. Whereas PRY is equal to 1 is the probability of the text region, and this is basically the probability of non-text region. So if we talk about the text boxes, the loss can be calculated with the help of insertion over union loss function. To use this loss function insertion over union because of its convergence rate, as it is fast and it has more accurate text localization capacity. So as a text box is basically the rectangles. So what they did is that loss of rectangle is my negative log of 1 over I over u, and r hat is basically the group map, the geographical map, which is being generated with the help of 5 channels, and r static is the basically ground truth value of the geographical location. Loss of geography is basically loss of rectangle, which is being calculated with the help of this equation, plus loss of angle from here. So if we talk about the rotation angle, the loss on this state can be calculated with the help of loss angle is equal to 1 minus cos theta minus theta static, where theta static hat is basically the rotation angle of prediction geometrical location, which is as I have mentioned earlier that we have 5 geometrical location. So this is calculated from there, and theta static is basically the ground truth value for that. So again, this is how the algorithm is working, and these are the equations which is being used for the calculation of the loss. And so further, if we talk about the results, as can be seen from that, that the loss after calculating the results, we see that the proposed method with the data set of 2015 is outperforming all the algorithms which are being used as a comparative algorithm. And similarly, if we talk about the table 3 results generated from the MSRD dataset, it also shows that the F-score of the proposed algorithm is higher than every other algorithm which is being used for comparison purpose. It can be seen from that we also see from the images that it is detecting each and every image perfectly, either it is in any orientation or in any direction. So this dataset, this algorithm was trained on basically 512 by 512 size of image which is being used. And for multi-scale images, this shows the proposed MS multi-scale detection images. Before detecting this multi-scale region, what the author did is that they resized the image into 0.2x, 0.3x, 0.5x, and 1.0x. For that, and these rescale images were again retained and were again used as an input in order to access the information. The recurrent percentage is that's why it's not, because they are using the resized multi-scale images on the same network which is being trained by 512 by 512 batches. So if we talk about other research work, which is basically also an end-to-end trainable neural network, it is known as the text boxes. They are fast and accurate in text detection. Besides that, they also argued about word spotting, which is being done with the help of integration of text boxes with convolutional recurrent neural network. So it is basically, as I have mentioned earlier, that text localization has 3 subcategories: basically character-based recognition, word-based recognition, and segment sequence-based recognition. So this is basically from the working object was basically from text localization. Category that is word-based category. It is and it is inspired by single shot multi-box detector work of the single shot multi-box detector. Why? Because single shot multi-box detector actually detect image with a single shot, for example with a single bounding box. For example, we want to extract information from that slide, whether where is the logo of the university. What single shot multi-box detector do is that it will simply just create a box that is ground truth box or the detection box at the edges of this circle in order to detect that this is the image which you are looking for. But the issue behind that is that it will not detect the text which is written in between that, or the text with the high aspect ratio, or the text which are in basically in the written over here in the with the different orientation or multi-orientation or in a single scale orientation. So for that purpose, the author proposed text box layer in the algorithm in order to access the text on the images, which is not being proposed by a single shot multi-box detector. So the data set they use are basically ICDR 2011, 2013 and Street View text. If we talk about the algorithm, which is can be easily recognized from the images, that what they did is that they extended VGG16 based neural network and converted the last 2 layers, fully connected layers with the parameter downsampling techniques and into convolutional layers, and added extra convolution and pooling layers. After that, multiple text box layers were added, which you can see after the last layer as well as in between few of the layers. So All of the multiple text box layers are receiving 72-dimensional vector images, which are being further processed to NMS. 72-dimensional vector images basically have different kind of information in it, which will need to be processed. So, as I have mentioned earlier, that they have introduced text box layers. That's why the functionality of text box layer might have some sort of loss. Before calculating the loss, I want to explain what text boxes are basically doing. It predicts the text presence and bounding boxes on the basis of the feature map, input feature map. Finally, we are given the images that on the basis of the features which are extracted from the image are being used as an input, and on the basis of this, these text box layers are creating bounding boxes and identify the text presence. Every map location, the classification score was offset to the associated default box. Every map location classification score was your associated default box. For example, the score classification was done on the convolution manner as because of associated default box are being used using the association values. For example, I will explain with that with an image example. For example, we have an image, for example, width and height, and the feature map extracted by them is basically the x and y. And so the box generated by the text box layer was can be so can we can see over there the box generated by this can be of, for example, text box is equal to x naught comma y naught comma w naught comma height naught. So what text box do is that text box will generate the values of these x, y, w, and h with the help of delta x, delta y, delta w, and delta h, with the help of some sort of confidence. Another issue which they have talked about is that of multi-scale images. So during training, what they did is that the ground truth box matched with the default box. For example, as I have mentioned earlier, that for example, let's suppose this is the ground truth box, and when the box generated by this text box layer, if it overlaps the ground truth box, it will be considered as accurate detection. Otherwise, it is considered as inaccurate detection. So we can see that in during images there might be some words which will be in long sense. For example, which will have a long text. For example, if we take this as a single word, then it is a long text, which might not be accessed by simple default box. For that purpose, what the author did is that they introduced a long box with the long aspect ratio, which will detect this text as a single long text. Therefore, for that purpose, what they did is that they introduced convolution filter of one steric 5 after every layer. What one steric 5 convolution filter do is that it will generate a long rectangle which will easily recognize a long text. So this is the basically main purpose of text box layer in order to detect the long text as well as the text presence and bounding boxing on that. After that, the text box was trained, and on the basis of it, there was a loss function which needs to be calculated, and loss was calculated with the help of this equation. What this equation told that x is basically the matching index matrix, and C is the confidence, L is the predicted location, and G is the ground truth. And where what N is basically N is the number of default boxes that matches the ground truth boxes, as I have mentioned earlier. And loss of location is calculated with the help of smooth L1 function, and loss of confidence was calculated with the help of softmax function. And so by putting those values in it, we will be able to calculate the loss of the text box layer easily. So if we talk about another aspect ratio about which they have discussed is that is multi-scale input image. So end-to-end text recognition basically means to access multi-scale input images. For that purpose, what the authors did is that they rescaled the input image into 5 different scales. That scales are 500 into 500, 700 into 700, 300 into 300, 500 into 700, 300 into 700, and 1600 into 1600. It was done. Why it was why they were rescaled? It was rescaled to detect or to increase the detection accuracy. And although they have achieved this detection accuracy, but they have to do trade-off in a form of computational cost. It increases the FMIS by 5%. When they are giving the input of 5 scales to the network, each picture which is taking 0.73 seconds in order to set the information. But when they eliminate 1600 into 1600 pixel image because it increases the size of the image, what happens is that every image is taking 0.24 per second in order to being processed. The main thing which need to be addressed over here is that they have used all those rescale image that is being used from multi-scale input image are also executed on the same network, which is being trained with 300 into 300 300 convolution filters. Okay, so on the basis of it they outperform, and which results in the high multiple pass in the multi-scale input images. After that, the other thing they argued about is, which I have mentioned in the introduction slide of this related work, is that of word spotting. As they claim that word spotting is the main thing which need to be addressed. Why it is the main thing? Because with the help of word spotting, we are able to, with the help of accurate word spotting, we are able to reduce the false positive or inaccurate predictions. For that purpose, they have adopted convolutional recurrent neural network. Because why CRNN? Because it helps in estimating sequence probability conditions on an input image. For example, we have a probability of the word sequence W of an input image I, which can be calculated with the help of this equation in order to get the scores. So where what W is basically the this big capital W is basically lexicon, which is containing the information of word library regarding the input images, and in this function max function will help us in accessing the score for the multi-scale input image. So the information which is being which text box received when the five different scale image were five different scale input were given for multi-scale input image, it will generate some sort of output, but it might have some false positive or wrong information. So for that purpose, what they did is that for multi-scale input images, they use the value generated by this and the score of this as a replacement of the existing values, because it reduces or it eliminates the false positive or incorrect information. After that, inputting that score in the text box layer, they have applied NMS, non-maximum suppression technique. What it do is that it eliminates the overlapping text box, which is giving the repetition or redundant output. So when we talk about the results, what it do is that text box is basically outperforming in each and every algorithm which is being used as a comparison algorithm. And specifically when we talk about SSD, which is the base algorithm for that, which is the base motivation, they have adopted, what they did is that they have adopted a our spread, and they have compete each and every value which is being generated by SSD. So this is basically the output of text localization. They located text with the high accuracy, with the high F values. And similarly, if we talk about word spotting and end-to-end results, it is also outperforming in each and every algorithm. All those algorithms adopted these data sets. And when the text was adopted these data sets for the evaluation purpose, what happened is that it outperformed in each and every data set. So if you talk about another work which is being done in the same category of end-to-end text recognition system, what it do is that it have generated end-to-end trainable book inventory management system, which is basically based on neural network based method. And they are as end-to-end categories have two steps, which is basically text localization and text recognition. Similarly, they have done this thing, and after that they have introduced calculated loss calculation with the help of introducing per time step classification. The datasets which they have used is ICDR 2003, SVT, and III5K. So while digging into this algorithm which we have introduced, the first step is called text localization, and second is text recognition. When we talk about text localization, there are two things which need to be addressed. First is basically the segmentation of the book spines. These are known as book spines. After that, the other section is known as the text localization. For that purpose, what they did is that for pre-processing technique, they use Hopf transformation. Hopf transformation basically detects the edges of the line and connect those edges in order to form a simple box, which helps in accessing the particular information or the edges. So for that purpose, the Hopf transformation is used as a pre-processing step, which helps us in extracting dominant orientation, on the basis of which we have to rotate the text. For example, we have these images and we have rotated that in a sequence, that one. After that, on rotated image, text, no text CNN convolutional neural network was trained on 32 into 64 color image patches in order to generate the saliency images, which can be shown in this, can be easily seen in this picture. What saliency images helps us in extracting book title, as you can see over here, and segmentation. Saliency, on the basis of saliency, we did is that we extract the book title and the images, which can be seen over here. It helps in accessing clear segmentation on the basis of the saliency images of the book spines. So this is basically what we have done, is that we have generated the segmentation. After that, the main purpose is text localization on the basis of multi-scale input images. For example, we have seen text algorithm was applied on each spine of the book in order to extract the words. It was performed by using region-based method, as it helps in generating extreme regions, because of which we get fast computation and high recall. After that, what happens after that? Generated saliency maps helps in removing non-text region. For example, these are the saliency images which we have generated, and we detected the text on the book spine, and these are the important information which are required by the algorithm, and all the other area which is not detected was basically non-text region. So for that purpose, multi-orientation text line algorithm was also applied on candidate text region to detect the lines of the text, because multi-orientation was an important feature, because the text written on the spines are of multiple orientation or within a straight line. After that, there is an issue which need to be addressed. That issue is basically identification of the text, whether it is written upside down or in the opposite manner. For example, we have put the book in the bookshelf in wrong direction. For example, the text is starting from the upper statement or lower statement, or the images direction is basically the upside down or down. So for that purpose, what happens is that it is necessary to detect the state of the line, either upside or downside. For that purpose, convolutional neural network was trained on 32 into 96 image patches with the help of binary algorithm or binary classifier. If the results of the binary classifier is 0.7 or more, then we have to rotate the image with 180 degrees Celsius. If the value is 0.3 or less, then we keep the value, or we keep the image in the same direction. If the value is in between 0.3 and 0.7, then we have to keep both of the results in order to extract the more perfect information. So why we use 32 into 96 patches for training with the help of binary classifier? Because it helps us in accessing more information from the book, so that we can get each and every information from there. So here we can see that we have access two things, which is basically time and in text localization, with data text segmentation and text localization. Now we will talk about the text recognition. In this paper, the author uses text recognition with the help of sequence labeling. What they did is that the authors adopted sequence labeling techniques, basically, which helps in identifying sequence of the characters instead of segmentation. For this, author used convolutional neural networks and recurrent neural networks, as it helps in casting scene text recognition as a sequence label on the basis of extracted features. For example, if we talk about this algorithm, by taking an input image, we might get what CNN will give us there. CNN will extract some features of the input image. For example, this is the input image I, and what CNN do is that it will extract some features like F1, F2 to FT. And what happens there, these which is further exploited by putting bi-directional long short-term memory modules, and generated features that are F line, in order to get another sequence that are the output of bidirectional long short-term memory, that will be x is equal to x1, x2 to xt. So what happens is that over there, that we got two features output there. From one of them is the CNN feature, and the other is basically the output of bidirectional long short-term. So as a final output from BLSTM, every output can be used whenever normalized through softmax. Every output which is being generated by the BLSTM was normalized with the help of softmax algorithm. for a specific labeling. Okay? So we are also expecting some final output which can be used as a final output, that is y is equal to y2, y1, y2, and yl. So when we talk so we from that output, it is clear that x and y have different length, that is xt and yl. So over here, as both sequences have different length, so it creates difficulty in training of this neural network. Therefore, what author did is that they have adopted CTC, connectionist temporal loss, in order to train the recurrent neural network. Why they adopted CTC? Because CTC allows recurrent neural network to train the network. Recurrent neural network CTC allows recurrent neural network for the training on different alignment. So for that purpose, what CT's convolution neural networks loss can be calculated for that thing, because while training we might face some sort of loss as mentioned earlier. For that, CTC x is equal to minus log p y of y belong to x, where y is basically the final expected output and x is basically the output generated by VLSTM. We can calculate Py that belong to x with the help of this equation, that is summation of a belongs to b minus 1 of y, p alpha belongs to x, where a is alignment factor, which helps in detecting per time step prediction that in relevant to the blank unblank labels and within the input image x, and b is basically the feature map, which removes repetition and the blank forms from the output. Repetition is basically like this: r is r and r is the repetition, and these dot are basically the blank labels. So with the help of this equation, we can calculate the value of p of y of belong to x, and with the help of this function, we can calculate the loss of while training convolution neural network and RNN. So further, so this is basically what happens when we talk about the CTC loss. So after that, what happens is that the algorithm face some sort of loss which need to be addressed. For that purpose, authors did that they introduced per time step classification. For that purpose, they trained CTC on the basis of per time step supervision in order to reduce the loss and in order to increase the efficiency of the algorithm. So during CTC training, blank labels dominate the output sequence. Okay, what does it mean? For example, we are giving an input image A, that is a polo, and we are expecting to have the ground truth boxes on each and every image, on each and every character. But what happens in reality is that they are giving the blank labels, which are much inside than as compared to the output characters that are shown is as an isolated peaks in different color: green, red, green, blue, 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 green. So in order to handle this kind of scenarios, authors introduced per time step loss classification, which need to be addressed. So to solve this issue, what per time step classification do is that it helps in accelerating the iteration speed and helps in order to get the perfect output. What happens in it is that while predicting only blank label, it results in high connections temporal classification loss, due to which model will do character prediction on a specific time step. On any defined specific time step, the model is doing the character prediction. But we are interested in doing the character prediction on every step per time step, not on specific defined step. Due to blank label issues, it also results in more iteration. So what per time step classification is that what it do is that it is generating the labels on every step defined, not on specific defined step, and also it is increasing the iteration. So for that purpose, per time step classification was introduced, and connections temporal classification was trained on the basis of per time step loss, where it can be calculated with the help of the given equation, which is being this given equation. If we talk about the in the form of input feature, that we have an input feature x, which is being described in the last slide. At any time step I, for example, if we talk about this image A, that let's suppose we can get on the labels on any character A, P, O, L, just like this, if and only if we are able to access and we are able to find ground truth box which is exactly overlapping the character, or or more than 50% it is overlapping the character, we will assign the value of x with the label z of any feature. Otherwise, we will not assign the character. Otherwise, we will not assign that character a label. So, which can be evaluated from that images that loss of per times the classification is equal to 1 over t, that t belongs to 1 is equal to I, minus negative log of p, that label of zi on any feature xi, which can be calculated with, which helps in accessing the loss of x. So, so another thing which happened after this thing is that the decoding penalty or layer was introduced, which helps in accessing the finding, which helps in finding the most likely output, that is y, from the input feature x. So for that purpose, we also need to calculate the loss function for CTC. What happens over there is that the decoding penalty function allows us to handle the incorrect prediction or false positive, because there was an issue in training that network. What issue is that? And during training the weighted CTC loss or in decoding penalties, what happened is that there was an issue of gap between objective function and evaluation criteria, and that issue was resolved with the help of introducing real loss function. For example, what they did is that they took the city's loss value as simple value, simple equation, which concatenated with the help of real loss value, that is le, for example, dot comma dot is the real loss value, and y is the expected output value, most likely y value, and yd is basically the decoding prediction. After calculating the weighted CTC loss in decoding penalties, what happens is that the weighted CTC will generate or inevitably emphasize the value of y. For that purpose, WCTC was set up, step up after each approach of the CTC training. After that, when we talk about the results of the algorithm proposed by them, we see that what is happening over here. The one thing I just forgot to mention over there is that that the lambda over there, where is this? The value of lambda is basically the hyperparameter. What it is doing is it reduces throughout the form as per time step supervision and only produce one alignment at a time. So when we discuss about the result, what happened over there, the CTC loss was trained on the basis of different objective functions. For example, base model, the character, on the basis of character level, which you can see over there, the character level and word level, in order to check the efficiency of the training data. So data was grouped on the length of y. Y is basically the output length, which have different, y is the output which have different length, which can be seen from the first slide, T and L. And so it was basically trained on the group data of the length of y. So there was a sudden jump in the beginning of loss. That's why there's a sudden jump at the beginning of the training data set. And at the end, when we, as I mentioned earlier, the hyperparameter is continuously reducing. And when we talk about the further, it is continuously reducing and reducing the training loss, which can be seen in the picture too, because it is a zoom picture from 1500 to 200 iteration. And it shows that almost loss was reduced with the help of per time step classification and hyperparameter. So if we talk about the results in the sense of expected text and in form of generating library inventory, we can see that these blue lines are basically the ground truth value, which means that we are expecting to have the result like this. But when we extract the data information from the spines, which spines and word extract from the spine, and the word was used as a query for the extracting of the information, the result obtained by this are basically using the same scenario and almost giving the results which are being expected by the data, or which is being expected by the algorithm. So when we talk about the numerical numbers, it shows that the proposed DSL at character level, word level, and basic is outperforming with the with the model which is being used as a comparative models. So now jumping toward the other section, other paper which is being used for end-to-end recognition system, is that what author did is that they propose idea works on the combination technique or approaches, and that is basically object detection and segmentation, object detection and semantic segmentation. Motivation behind this study is to overcome the issue like arbitrary text orientation, and aspect ratio variation. So for this purpose, they created rectangles by detecting the corner points of the words regardless of their size, of their aspect ratio. Secondly, what they did is that the region segmentation was performed to detect effective text localization information. The dataset what they use are basically ICDA 2013, 2015, and TD 500. So this is what I'm just going to explain. What does that mean? That they detected the corners, not the text boxes. So what they are doing is that we can see from the picture that they detect the first corner, then the second corner, then the third corner, then the fourth corner in the clockwise direction in order to form the triangle with the side over while overcoming the size or aspect ratio and orientation of the text. And the second step, what they did is that their region segmentation was performed on the basis of these corners there, or the basis of the region segmentation, which is being performed in order to make a full triangle. I will broadly explain. I will explain that thing in the further slides. So if we talk about the general architecture or overview of the method proposed by them, what it does is that is taking an image, and after that it extracts the features. On basis of feature, they identify corner detection and position sensitive segmentation and do sampling grouping. With After that, what they do is that every score was identified on the basis of the sample grouping, and numbers was applied in order to extract the information. So what is happening in feature extraction? What they did is basically they extended the VGG16 model, extend with the 16, I converted last two layer as a convolutional layer, and also stacked the more convolutional layer on the VGG16. After that, they have added decoded layer, which is shown in the pink color. What they do is that it was done to enlarge the receptive field of extracted features. It was done to enlarge extracted feature. For example, what it does mean by enlarge the receptive field for extracted feature mean that we, with the help of decoded layer, they are extracting each and every information which will detect the text region, non-text region, and everything which are needed in order to identify the corner points. Because if we are connecting the, if we are adding the non-text region, we will not be able to identify the corner point. So the 6 deconvolution modules were with the 256 channels were introduced in it. After that, the extracted information from the deconvolution module and the convolution layer which they have added was used to detect the corner points and predict position sensitive maps. So when we so this is basically basic architecture. And the two things which they have performed are basically corner point detection and position sensitive segmentation, which is being shown, which is clear in this images. So when we talk about the corner point detection, what it do is that what is happening over there is that, as I have mentioned earlier, that they determine rectangle on the basis of corner point regardless of the size, aspect ratio, or orientation. So what they do is that they basically detect corner point in a clockwise direction. What is clockwise direction? You all know that 1, 2, 3, 4 are the clockwise direction. Top left, top right, and bottom left, in order to detect the text region instead of text box directly, as that what is happening in the second article, which I have explained, that they are generating a text boxes just like SSD. So after the candidate box was generated by sampling and grouping detected corner points, and sampling grouping, the detected corner points are with the help of which we have detected a corner point and eliminate the unreasonable boxes by segmenting information. Okay, so if we have a rotated angle, for example, if we see the image in which we have a rotated triangle, we can say that we can have the rotation triangle axis with the help of x, y, and width and height, and some sort of any angle which need to be addressed because we have rotation in an angle. So we can represent the corners of the respected triangle within the two-dimensional factor. For example, this can be seen say as x1 y1, x2 y2, x3 y3, x4 y4. Proposed technique detect corner points with the help of default boxes in a way that they should output classification score and offset. Classification score in the corner point and offset scores. So, for example, classification score and offset scores should be for the all 4 corner points. Okay, which is relevant to these corresponding corner points. And what happens after that is that the prediction module basically adopt all the convolution corner points values in order to predict the score and offsets in two different branches. So to handle the computational complexity, a 256 filter was used for an M into N feature map. For example, we are giving an input this, and for that we have 256 as shown in this decoding filter value, decoded layer, which is being used over here as an F1, which is being trained with the help of 256 filter for any M into N feature map, which is being generated with K default boxes in each cell. Score branch will output the value 2 and offset branch will output the value 4. 2 and 4 for each corner points which is being detected. So what does this 2 and 4 mean? That 2 and 4 mean shows that the value of these 2 and 4 tell us basically the exact location of the corner point, that there is a corner point of that word. So in total, the output branch will have, the output and score branch will have K into Q into 2 and K into Q into 4 values. What the Q is basically the corner points, that is basically in the 4 by default are the 4 corner points, and K is basically the default box into corner points into 4 and default box into corner points into 2. So why I said in the beginning that we need to convert this values into two-dimensional, because there are rules on the basis of which we are detecting these corner points. The first one is x coordinate of the top left and bottom left corner point must less than the x coordinate of the top right and bottom right corner. Similarly, the y coordinate of the top left and bottom left should be less than the y coordinate of the top right and top right, in order to help in accessing the corner points and making the triangle. Because of this values we have obtained in two-dimensional values, the original ground box can be represented and rotated triangle with their relative position. For example, we have a rotated triangle R is equal to P of I that belongs to I, such that I belongs to 1, 2, 3, 4, which is the corner point, and P of I is basically to xi and yi. Xi and yi are basically the corner points in the clockwise direction. So this is what they have did. This is what they have done, and this is what they have done in the corner point detection. So if we talk about position sensitive segmentation, what is happening over there in position sensitive segmentation is that this is the second step which they have performed in order to detect the words. So in position sensitive segmentation, region segmentation map can provide efficient location. Region sensitive can provide efficient location information of the text as they provide segmentation map instead of text no text map. These maps were used to score candidate box. For that purpose, they have proposed a layer. I will explain that layer at the end, which helps them in accessing the position-sensitive segmentation. They predict text region and score simultaneously. Previous techniques face overlapping issues, which results in inaccurate prediction of the text pixels. For that purpose, they use position-sensitive segmentation for generating segmentation map. Okay, segment. For example, we have text bounding box. For example, we have text bounding box this. Okay, which have 4 bins. I will explain how we got there bin. We have text bounding box R, which I have explained in the last slide. R, as explained, and with that R is divided into a grid of G into G, which helps in dividing that grid into 4 bins, equal bins. So those bins were used to extract the information or the pixels. How we can extract that pixel? For each bin, a segmentation map is used to determine the relevant pixel for all the relevant bins. Both position sensitive segmentation and corner point were working uniformly because they, in position sensitive segmentation, they reuse the decoded feature, that is F3, 4, 7, 8, and 10, and build convolutional blocks with residual blocks. A corner point detection, for example, if you can say that all the values obtained by this F4, 7, 8, and 9 were rescaled into the scale of F3 by adopting the scale of 2, 4, 8, and 16. So in order to get the same images, same information, they rescaled those in order to get the exact pixel of the relevant box. Further added de further added deconvolution 2 into 2 to enlarge resolution so that the last deconvolution to have G into G, which helps in determining relevant points of the relevant pixel in the relevant bins. So these are basically the two things which they have performed in corner point detection and position sensitive segmentation. So we can say, as we have mentioned earlier, that there is some sort of loss which need to be addressed, and both these things are corner point detection and position sensitive are working uniformly. So there is need to calculate the loss, which is being calculated uniformly with the same equation we can see over here, and see what it is being what are they telling us, that basically L and C is basically loss of confidence is basically loss of the score branch, and loss of location is basically loss of the offset branch, and loss of segmentation is basically loss of position sensitive segmentation. And NC is basically the positive default box, and NS is the pixels in segmentation map, and they both are used to normalize corner point and detect corner point detection and segmentation, whereas lambda 1 and lambda 2 are the balancing factors, which are by default set as lambda 1 is equal to 1 and lambda 2 is equal to 10. We want to, if we are to calculate the loss of confidence for score match, we use a cross entropy formula, where YC and PC, YC is basically the ground truth value and PC is basically the predicted score. And loss of location is calculated with the help of smooth L1, Y1, P1, YL, PL, whereas YL is ground truth value and the predicted offset value. So loss of segmentation is basically is equal to 1 minus 2 ys ps, ys plus ps, whereas ys is the position sensitive segmentation and ps is basically the predicted of segmentation module. So at the end we are going to discuss the sampling and grouping, and sampling, grouping, and scoring. As we have explained in the first architecture, that the last step is sampling and grouping and scoring. So we are going to explain this thing in it. Now what is going to happen, that when we sample or group the images, we might get a lot of candidate boxes. For example, uh, yellow is the candidate box, where by sampling we get a lot of candidate boxes which need to be addressed. So what happens in the scoring is that because we have a large number of candidate bounding box, that can be the output of the sampling and grouping corner points. So to handle those rotated large number of text bounding box, uh, and what they did is that they proposed a rotated position sensitive ROI average polling layer, as which I mentioned earlier, that I will explain that polling layer which they have introduced in order to handle those large candidate boxes. So for that purpose, what they did is that what the large convolutional polling layer do, that it splits the box into a bin of G into G, which I have explained. Then rectangles for each bin is generated with minimum areas to cover in bin. Then calculate the mean value of all the pixels within that defined bin. So in the end, the score of rotated bounding box is obtained by averaging mean of G into G bin. This layer, what will happen, what will the average polling layer will do is that basically it will keep all those candidate box which are having the value greater than 0.6 and eliminate all the rest of the boxes with the value having value less than 0.6. So we consider this is a candidate box, and these are the position sensitive segmentation which is being generated in the bins, and after that the bins are being calculated in order to find the average scoring box. And the last step, which is after that, what happened is that the NMS was applied non-maximum suppression techniques, which helps in detecting or removing the recurrent overlappings in order to find the final value. So if we talk about that thing in numeric, it shows that all the all the proposed techniques, results of the proposed techniques in all the data sets are all performing the results. I'm just using few of the data, a few of the results which are being used. So according to my direction, what I'm thinking and what I'm planning to do is that I want to apply these end-to-end recognition system on the hazy images, which is being which are being encountered during the driving or within a dense fog or in the darkness. These hazy images are need to be uh, purified or edges need to be cleaned, so in order to detect the exact value so that we make a decision on them. And the other thing which I'm expecting to do is that you need to implement the end-to-end system on the Urdu language character level recognition, as this is the main feature. I think I need to work on this. As I did not have any. I would like to have your suggestion on my work. That will kindly suggest me anything if you want me to improve, so that I will continue working on that thing. So in the end, if we talk about the conclusion, I have explored various techniques in end-to-end text scene text detection and recognition, because there are a lot of challenges which need to be addressed while in detecting the text that are because the images are not clear, low resolution, small text, and maybe some alignment issues. So many other challenges which I have mentioned in earlier. So we have learned multiple ways of detecting syntax from this algorithm like CNN, RNN. We have learned how to calculate the loss, and we have learned how different methods of detecting the words. And these are the resource references which I have explained and which I have done in my report. And I will provide further references as well, which I have studied for these things. And if you want to have further references and discussion, you have my email address, which I have mentioned in the first slide. So thank you very much. This is all from my side. And if you have any question, you are welcome to ask the question. I will answer. Will try my best to answer those questions, and will like to learn from you people that if I have done something which need to be improved, I will love to have a recommendation from you people. Thank you very much.